my dear students, welcome back to my channel. My name is Prachi Sharma and this channel is about learning chemistry for 10th grade ICSE. Now if you are new to this channel and if you are struggling with anything in chemistry for 10th grade, make sure that you stay tuned on this channel because we have a lot of stuff here. We have one-shot videos, important questions, sample papers and also mind mapping videos. Now, let's get started with today's session. In today's session, we are working on important questions or PYQs of chemical bonding. Again, like electrolysis, this will be divided into two parts. So in this video, we'll be working on some important questions and then you'll have a second part for all important questions for chemical bonding. So let's get started. Alright students, let's get started with part 1 of important questions for chemical bonding. So let's quickly start with the first question. Now another important thing is that as you remember that in the important question series I'm not writing all of the answers on the screen because I'm trying to keep the video short and writing the answers make it a bit longer. So let's get started. We'll be discussing all the questions. For any doubts and queries that you don't understand during the video, you are free to drop a comment in the comment section, a message on the Telegram channel, or you can also write me an email on psclassesicsc@gmail.com. So let's get started with the first question. Draw an electron dot diagram to show the structure of hydronium ion. State the type of bonding present in it. Now this is a very important question. If you would have done some sample papers or PYQs, you would realize that hydronium ion is asked a lot. That means you have to draw the electron dot structure of it and explain, mark the lone pair or also mention what kind of bond that is. So let's get started with this one. Whenever you draw a hydronium ion electron dot diagram, you're always supposed to show the water molecule plus H plus ion and then combine them and give a hydronium ion. That is the correct method of drawing this structure. So let's get started with it. I'm just making a rough diagram for you. So you'll have oxygen. It will have all the electrons right here. Then you have two hydrogens combined with that with one electron each. It's sharing. Plus you'll have H plus ion combining. And this H plus ion will get connected. This lone pair will move there towards H plus ion. So what will you get? You will get something like hydrogen, oxygen, two molecules here, one hydrogen bond here, and then a lone pair being shared with this hydrogen, and the entire sign or the charge on hydronium ion would be positive. Now what kind of bonding is this? This is a coordinate bond. Okay, let's move to the next question. Next question says the bonding. Okay, bonding in this molecule can be understood to involve coordinate bonding. Option A is carbon tetrachloride. Of course, no. Then hydrogen, hydrogen chloride, and ammonium chloride. So, ammonium chloride is the one that would involve coordinate bonding in that. Now, let's move to the next one. Now, this says explain the bonding in methane molecule using electron dot structure. Now, methane molecule is very direct. That means you have one C and four H's with that. Now, this is a regular structure, but when you're supposed to draw an electron dot structure, you have to mention the electrons. That means either represented by dots or represented by X, and then you can make the bond like this. So, this is our electron dot structure. Now, let's move ahead to the next one. An element L consists of molecules. So, molecules, what type of bonding is present in the particles that make up L? So when we have molecules present, that means this particular bond is covalent bond. Now let's move to the next one. There are three elements E, F and G with atomic numbers 19, 8, 17 respectively. Classify the elements as metals or non-metals. So first of all, if you think about this, this is 19. That means 2, 8, 8, 1. Then you have 8, so that would be 2 and a 6. Then 17, so 2, 8, 7. Now, when we have tendency to donate electrons, that means that particular element is a metal. So, in this case, if you think about this, this one is a metal. That means 19. is a metal and other two are non-metals because they have a tendency to accept electrons to complete the octet. Now let's start and look for the answers. So for metals you will say E is a metal and F and G are non-metals. So F and G are non-metals. The next part is give the molecular formula of the compound formed between E and G. So E will accept one electron and G will E will donate one electron and G will accept one electron. So 1 1 and they will be satisfied. So what kind of bond will form? We'll have EG. Okay, so you're using one atom of E and one atom of G. So your molecular formula would be EG. And then they're asking, state the type of chemical bond in this compound. So if we see that one of them is ready to donate, the other one is ready to accept. So what kind of bond that would be? That would be ionic bond. So we mention ionic bond. Now let's move to the next one. A compound X consists of only molecules. Hence, X will have dash. Now as we know that compounds that form molecules are ionic in nature. So like from these, you just have to pick up which one of that would be the correct property. So a compound X consists of only molecules. Hence, X will have, sorry, it would be covalent bond, not ionic bond. It would be covalent bond. So X would have A, crystalline hard structure, B, a low melting and boiling point, C, an ionic bond, so not C definitely, a strong force of attraction between its molecules. So if you know from the properties of covalent bond, it should have a low melting and boiling point. So your answer should be B. Okay, let's move ahead to the next one. Why do covalent compounds exist as gases, liquids, or soft solids? So let me see. I hope. Okay, so the next question is not that. The next question is the molecule containing a triple covalent bond is. So which one of these will have a triple covalent bond? So the answer for this would be nitrogen. Nitrogen contains three covalent bonds between nitrogen atom. Now, I think I read the next question. That was, okay. So, why do covalent compounds exist as gases, liquids, or soft solids? That is because of the force of attraction between the elements. So, because of that, you have them existing as gases, liquids, or soft solids. Let me write that for you. The force of attraction between the constituent particles is weak, and since this particular force of attraction is weak, therefore they are easily able to exist as gases, liquids, or soft solids. Okay, let's move to the next question. The next question is why hydrogen fluoride can be termed a polar covalent compound. Now what do we mean by polar? So in polar, one of the element is highly electronegative and has a tendency to pull the shared pair towards itself, and such compounds are known as polar covalent compounds. So the chlorine is more electronegative because chlorine is highly electronegative, and since it is more electronegative, it has a tendency to pull the shared pair towards itself and attain a slightly negative charge, leaving hydrogen with a slight positive charge. Therefore this kind of bond is a polar covalent bond. Let's move to the next one. Fill in the blanks from the given choices. So you have the choices given. First one is, in covalent compounds, the bond formed is due to the sharing of electrons. That's easy. The second is, electrovalent compounds have dash boiling point. So electrovalent compounds have high boiling point, whereas covalent ones have low boiling and melting point. Let's move to the next one. Now they are saying, by drawing an electron dot diagram, show the lone pair effect leading to the formation of ammonium ion from ammonia gas and hydrogen ion. Okay, let's draw this one. I have space, yeah. So let's draw this one. So first of all, you have to draw is ammonium ion. So when you're drawing ammonium ion, you'll have a nitrogen here. You'll have hydrogens around that. and this would be a slight positive charge which you are adding in your ammonia. So this is sharing one electrons. So you can make the bonds like these. You can also make the electron dot structure. That means showing one of the electron as a dot and the other one as a cross and making the bond. You're adding an ion to that, and that will form nitrogen. This is a lone pair, and then a hydrogen, 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 and then the entire formula will have a slight positive charge on the top. Okay, now let's move ahead to the next one. Name the bond formed by a shared pair of electrons with both electrons coming from the same atom. So when do we have a pair of electrons coming from the same element or same atom? In that case, it's a coordinate bond. Let's move to the next one. Among the following compounds, identify the one that has all three bonds: ionic, covalent, and coordinate bond. So which one of these will have all the three bonds? So ammonia, no. Ammonium chloride, yes. Ammonium chloride will have all the three bonds in it. It will have ionic bond, covalent bond, and coordinate bond. Now let's move to the next question. Which of the following is not a typical property of ionic compound? So ionic compounds have a high melting point, that we know. They conduct electricity in molten and in aqueous solution. Yes, we know that because they can easily break down into ions and hence a good conduction of electricity. Then the next is they are insoluble in water. Yes, this is not a typical property of ionic compounds because they are soluble in water. Then the next is they exist as oppositely charged ions even in the solid state. No. So, oh yes, they exist as oppositely charged ions even in the solid state. Yes. Then question 15, column A and column B, you have column A sodium chloride, ammonium ion and carbon tetrachloride. On the other side you have covalent bond, ionic bond, covalent and coordinate bond. Now you have to answer the following questions. Correct item from B matching sodium chloride. So sodium chloride will be matched with ionic bond. So your answer for this case will be ionic bond. Then the next is correct item from B matching ammonium ion. So ammonium ion will have a covalent and coordinate bond. We just did the structure of it. So you'll have the answer as covalent and coordinate bond. Then correct item from B matching carbon tetrachloride. So carbon tetrachloride is a typical covalent compound. So you'll match it up with covalent bond. But you have to write the proper names. If you have any confusions on how to write the answers, you can check out the sample paper 2 video in which I have discussed how you should frame the answers, how much information you need to write in the answer. So you can check out that video. Let's move ahead to the next one. Electrovalent compounds have high melting and boiling points. The next is an element with the atomic number 19. So atomic number 19 means 2881 will most likely combine chemically with the element who has an atomic number is dash. Okay, so you need to combine it with an with a compound which has at least 7 electrons in the outermost shell. So this will be 287, this will be 281, this will be 2882, then this will be 288. So it has the highest tendency to combine with this one. So your answer should be A. Okay, let's move to the next one. Identify the term in the following. The electrons present in the outermost shell of an atom is valence electrons. Okay, let's move ahead to the next one. The question is, the following table shows the electronic configuration of the elements W, X, Y and Z. Then you have the elements written, electronic configuration written. Answer the following question based on the table above. What type of bond is formed between W and X? So you have W here, you have X here. So one of them is giving one electron, the other one can accept one electron. So this is a ionic bond. So for this you will mention ionic bond. Then next is Y and Z. So Y, where is Y? Y is this and Z is this. So you'll have a covalent bond here, because you can have about 3 Z's combined with a Y, and they can share one electron each. So both of them will be satisfied. So in this case, the answer will be covalent bond. Let's move to the next one. What is the formula of the compound formed between X and Z? So you have X and Z, these two. So one of them can give one electron, one of them can accept. So your formula, that means we are using one atom each. That should be XZ. So you can write ZX. Then the next is between W and X. So W and X is 7 and 1. So WX, that's direct. WX. Now next is, by drawing an electron dot diagram, show the formation of ammonium ion. So we have already discussed that you have to show the formation. That means first make the N, then crosses, then you have the hydrogen, you have extra one here, then you have hydrogen, so 3 hydrogens, dot and a dot, and then you can show these 3 covalent bonds combining with one H ion, and this will give you what? This will be N. Then this is lone pair being shared with one H, one hydrogen covalent bond, and the entire thing will have a sign of positive on the top. So now let's move to the next one. Sodium chloride will conduct electricity only in fused or aqueous state. Give a reason. This is because when you have sodium chloride in fused or aqueous state, in that state it loses out, it breaks down into ions, dissociates into ions, and this dissociation and the presence of ions in the solution help in conduction of electricity. Whereas if you talk about solid state, in a solid state you do not have any free ions which can conduct electricity. So that's the answer for this. Let's move to the next one. Choose from the following the ionic compounds, the polar covalent compounds and the non-polar covalent compounds. So you have the first one as NaCl. So we know NaCl is ionic. Then methane is non-polar covalent. Then we have oxygen molecule, that is also non-polar covalent. Then we have hydrogen chloride, which is, of course, we know that it's a polar covalent compound. Then you have calcium oxide. Calcium oxide is ionic compound. Then you have ammonia, which is a polar covalent compound. Now we have named the following. So the first one is, okay, you just have to give in an example for it. Okay. So the first one is a polar covalent compound which on dissolving in water produces ions. Okay. So you need a polar covalent compound and it's giving you ions when you dissolve it in water. The best answer for this should be hydrogen chloride ion. So you have not ion, hydrogen chloride gas. Hydrogen chloride gas. The next is the type of bonding present in metallic chlorides. So when you have metallic chloride, so metals are in the first or the second table in the periodic table, chlorine is in the last. So they have a high tendency, or they would always, majority of them will make ionic bonds, because metal will easily lose one electron and chlorine will easily gain one electron. So this would be ionic bonds. Then the next one is the type of bonding present in non-metallic chloride. So non-metals. Non-metals are more towards the end of the periodic table when you go across a period. So in that case, non-metals have a tendency to gain electrons. And we are talking about non-metallic chlorides. Chlorides also have a tendency to gain electrons. So instead of gaining or losing, they will end up sharing. So in this case, your answer will be covalent compounds. Now the next is the bond formed by the mutual sharing of electrons, covalent compounds. So we are talking about covalent bond. Then the next is the bond formed by the transference of electrons. So when we have electrons being transferred, those type is known as ionic or electrovalent compound. So let me write that. Ionic compound. Now, an ion formed by the loss of electrons from the neutral atom. So when we have loss of electrons, we are talking about cation. Then An ion formed by the gain of electrons. So when we have gain of electrons, that means a negatively charged ions is an anion. The next is the outermost shell of an atom is valence shell. The electrons present in the outermost shell of an atom are valence electrons. Then we have elements having 8 electrons in the outermost shell are known as inert gases or noble gases. Okay, students, so these were about 23 questions that we have covered today. All right, students, so this is it that we will cover for today. We have successfully covered about 23 questions which are very important and which they're given in the previous year board exams. So make sure that you go through all of the questions thoroughly, understand the answers, and let me know if you have any doubts from that. And a second part of the same topic will be also coming out, that is important questions for covalent bonding also. So thank you so much. I hope you have a beautiful day ahead.